Hello everybody. In this video we're going to be talking a little bit more about a concept I introduced last time called the move block. So the move block is actually the very first block that you get up here when you're on this green circle tab. So the move block is basically what allows your robot to move. It gives your robot mobility, allows it to go from one place to the other. So if I left click on the move block and I get a little icon and I can drag it so that the three highlighted blocks are on the start or near the blue start square. So I put the block right on top of that start square. So see, I see this blue start square that says start appear there, and if I drag my block straight onto there, it gets put onto this thing. This thing right here is called the sequence beam, and the sequence beam is all the things that are being executed that are going to happen in your program. So talking a little bit more about this, so looking a little bit at this move block, we see that it's green, it's got these gears on it. Now it's important not to confuse this block with this block, which we'll talk about both blocks eventually, but do not confuse this block. This block is a big no. Use only this block for right now. It's got a dark green color and it's got 2 gears instead of 1, and it has another key indicator is that it's got these 3 check boxes as opposed to the other blocks. It's got these little buttons and you can only select one. So that's very important. It's got a couple of basic icons here, which really mean nothing until you look at the customization. So if I click on the block, I go to see all the options. In NXT, we have 7 total ports. 3 of them are labeled A, B. Each of them is labeled with a number or a letter. One of them is named A, B, and then another one named C, and then the other 4 are named with the numbers 1 through 4. So the motors BC, the B and C ports are used for driving. A lot of people think it's actually the A and B ports because A and B are the first 2 letters, but that's actually not right. It should be the B and C ports because A is for the arm. So always remember that A equals arm. A equals arm. So always motor port A is arm, BC is driving. So remember the A is equal to arm, then you'll be in good shape. Looking at it some more, we see that we can select all 3 of the ports. If we select all 3 of the ports, well, then some of the options are disabled, and we'll talk about that a little bit. If we select only one port, the same options are also disabled. So we select B and C because we want the robot to move with those. NXT motors can only rotate in 3 directions, either forward, backward, or they can't move at all. Stop. So the forward direction, because the motors can only rotate forward and backward, that's why they have the additional option of steering. Steering is how you actually get your robot to turn. So remember, direction is for the motors and steering is for the robot. Motors, robot. Motors, robot. So this slider is pretty self-explanatory. You slide it to however much you want. Now, keep in mind, if you want your robot to try and turn on a dime, you'll want to put the slider all the way to either the left or the right. This makes sure that your robot can turn in place. If you choose anything else, even though it may look like 90 degrees, your robot is actually going to make an arc, and you don't want it to make an arc unless you're actually trying to do that. So remember, either perfectly center, all the way to the left, or all the way to the right. Power is actually how much power is applied to your wheels, which actually correlates with speed. More power usually means more speed, but not always. If you have a task that requires you to lift something, you may want to put more power, but you're not necessarily going to get more speed. You will do more work, which is basically you will expend more energy, but you won't necessarily get more speed, although when you're driving forward, you may get speed as a result. Duration is one of the most confusing topics of the move block. Duration is basically how long the robot should go. Now, there's some debate as to whether unlimited is really unlimited, and people are worried that for a long time, people were worried that if they set unlimited, the robot would go on forever and they would never be able to stop it, until it, of course, ran out of battery or broke. This is actually not true. The people at Lego Mindstorms who wrote this software decided that they're going to set a limit for unlimited. In reality, it's probably about 3 to 5 rotations before your robot will automatically stop on its own. If you want your robot to go truly unlimited, you'll have to drag out a loop block and put it inside, and we'll talk about loop blocks later and why this works. You can, however, make it go almost unlimited by setting a large number of all the other options. Seconds is the easiest to comprehend. It is how long the robot should move. If you want the robot to just move forward for 10 seconds, then you put in the number 10 and it'll go forward for exactly 10 seconds and then it will stop. Rotations is like the rotations of the motor. One rotation is comparable to 360 degrees. But we'll talk more about why this is not true for Lego Mindstorms. But if you think about a rotation, it's a full rotation of that orange circle on the motor. So you can set for about 10 rotations, or if you wanted to go 10 rotations and then half a rotation, you can optionally put a decimal number in there. So you can put 10.5 or 10.25 if you're good with fractions. Degrees is actually how many degrees the motor turns and not necessarily how many your robot turns. You can try this for yourself by putting in the number 360 degrees. Then compare it, put that program on your NXT and run it, and see what happens when you put 360 degrees versus one rotation, and see how far your robot goes. You'll find that the robot doesn't actually move one rotation forward, but actually moves a little bit less. Why? Because of the fact that the robot that only the motors turn, but degrees is for the motors, and rotations is also for the motors, but it's a little bit more accurate. To make this point a little bit clearer, I'd like to talk a little bit about how the motors are set up. But the motors are sort of set up like a servo motor. You have the main wheel component, which will be about these 4 squares right here. And then you have a major big body, that's where all the gears are located. That orange circle that you see, that orange tip where everything is connected to, that is the part that actually turns 360 degrees. Now, your wheel may be much bigger than that. Therefore, your wheel will not rotate. Your wheel may or may not rotate 360 degrees. And your robot, even though your wheel may rotate, your robot may not actually move that far. So be careful when using degrees. Degrees are usually for precise measurements. If you wanted a motor to specifically turn 90 degrees, then you may have to enter a bigger number like 362 to make it turn 90 degrees. Isn't that a funny concept? So degrees are precise. A lot of people will often use rotations to drive their robot until they get close to their goal, and then they'll switch to degrees and just use this bigger number. The next action is quite simple, actually. Brake is basically having your robot come to a hard stop by physically prohibiting the motors, the gears from moving. This brings your robot to a dead stop right where the action ends. When you coast, you're simply turning off the power to the motor and just letting the robot slide. Coasting is less accurate but uses much less power, and is often preferred over braking unless you're talking about accuracy. The move block can actually be kind of complicated, but it's actually very easy once you get used to it. Remember that always it should be the dark green circle with the little tiny circle over here, and not the single gear with the lighter green color. If you do all this and follow it, you'll be perfectly fine. Thanks for watching.